Let's talk now about combining forecasts in the MLP model with the mean or the median, and what implications that may have. So we'll come back over here, and in this example, we're going to look at the cardiac particulates and temperature data set. We're going to look particularly at the particulates data. So that's what I've pulled up here. It looks very periodic. Remember, this is weekly data. And so that's what we've got, a few years here of weekly data on particulates in LA. And so what I really want to show here is I'm going to go ahead and get this started, actually. It's going to take a little bit of time, is we're going to set the seed of 13. I had to pick 13 because this isn't by any means common, but it's not all unlikely. This phenomenon that I'm about to show you is that, remember, like in this one, I've got a relative, for sake of example, I've got 10 repetitions. So it's going to go through and do 10 repetitions. And then the forecasts will be the mean or the median or the mode of those 10 repetitions. And does it make a difference? And we're going to show that it does in some cases. So right now it's given a frequency of 52. We did say diff order. There's no difference. We're going to let the combination of the forecast be the mean. There are also things we'll talk about in the future, these deterministic seasonal dummy variables, which are just indicator variables. There'd be 51 of them for the 52 levels of week, but we're not allowing those right now. It's just a purely correlation-based model, and it looks like it's finished. So we'll go ahead and look and see what we've got. So this is looks like it's looking at lags 2, 3, 4, 6, 12, all the way to 51. And we'll see what kind of performance we get from that. But looking at the architecture of that model, there's one of these inputs for each of those lags, and that's it. So let's go ahead and do the forecast. We're going to forecast with that model 52 weeks out, 1 year in advance. And we go ahead and do that. And then if we want to plot it, we can look at this. And notice that this is going to be the final forecast here, are the mean of the 10 forecasts that come from those 10 repetitions. So I'm going to go ahead and do that. And we can see in this particular one, in these 10 repetitions, a couple, not even just one, but a couple of the repetitions really produced forecasts that were very, very, very negative, right? Particulates can't be negative, so that's not even realistic. But when you take the mean of those, we see this kind of almost sinusoidal pattern of particulates. And then we've got this kind of, in a year, this kind of bimodal dip in there, which doesn't look very accurate, but we can see, or practical, but we can see why that is, because it's taking the average of these very, very low numbers. So I should have been doing this the whole time around, because we're going to have to wait for that a little bit, but I'll go ahead and run it. So now it's doing another 10 repetitions, but notice that it's going to combine using the median. And we know that the median is... resistant to these outliers, and so it'll just take the middle one, and we'll see if we don't get better looking forecasts that kind of match our intuition a little bit better. But we're going to wait. Again, we're not allowing these seasonal dummies. We'll talk about that in a little bit later. And let's just go ahead and let it think here for a moment. Okay, and it's all done. So we'll go ahead and look at this. Again, we set the same seed, so it should have given us the same model. But this time, note that we should have, these gray lines shouldn't move at all, but we're going to be taking the blue will be the median of those now. And when we do that, a much more reasonable model there. So the general guidance is to use the median because it's not sensitive to these sometimes really rogue repetitions that can happen with certain starting values of the MLP with the gradient descent. But that's the recommended nature is just to choose the median, but it's an option, of course. So now we'll look at the same idea with the melanoma and sunspot data, recalling now that we're going to be forecasting the melanoma, but we're going to be using sunspot the sunspots as an explanatory variable. Again, we're just comparing the mean and the median here, but let's check it out. So for seed equals 1, turns out you can use a lot of different seeds here. I'm just going to fit the melanoma model with these sunspots as the XREG, and we're going to not allow the seasonal dummies, but we'll see what happens here. So we'll go ahead and get that going. That shouldn't take too long. And we see the results here. We have an explanatory variable with a few lags and the univariate lags on the melanoma. Now that's fitting the model, Now we want to forecast with that model. So if we want to forecast, in this case, the next 8, we're going to have to first forecast the next 8 of the sunspot, because at that time, if I'm trying to forecast next year's melanoma, I don't know next year's sunspots. And if I'm trying to forecast next year's or 8 years from now melanoma, I won't know 8 years from now sunspots. So I'll need to forecast those. So I'm going to go ahead and forecast those here. That's what this is doing. So I'll go ahead and do those forecasts. Now this step here is just to do some data wrangling, data cleaning. It's packaging up those 8 forecasts into a data frame and then creating a final data frame that has the known data point, the known sunspots, and then the 8 tacked onto the end of it. So that's just giving us the 8 the known ones that we have, and then the 8 forecast ones on the end. And that's what it needs. That's what NN4 needs to forecast. So notice that's called SMDF, and that's what we're passing in here, SMDF. You might think that it just needs the last 8, but it needs all of them if it's going to look back for the first forecast. It needs to look back into the ones that we actually have. So that's all the ones that we need. So I'm going to go ahead and forecast. Notice I'm forecasting a horizon of 8 from that original model that we fit up here, and then I'm going to give it the known ones and the ones that we have on the end. So that we forecasted. So I'll go ahead and do that, and that's done that. Notice that we're using the median. That's where it would, I'm sorry, up here. That's where we're saying how we're going to combine those using the median. And then we'll go ahead and look at those. So those are the actual forecasts, but those are the medians of those 10, right? We use 10 repetitions. So we'll go ahead and see it here. And so that's the melanoma data, and those are the 10 repetitions, forecasts from the 10 repetitions, and they look pretty evenly distributed top to bottom. And so the median is just the middle of those. And so I'm going to go ahead, this is the same idea, except notice that we're using the mean here. So I'm going to go ahead and plop that on top of there, and we'll look at the mean, and we're not going to see that it moves around too much, right? Because there weren't these extremes and small values or these extreme large values. Notice it didn't move around very much. So that was the median. I have to skip one in there. That was the median, and that was the mean. So that is not a huge difference, obviously, and you can see why, because again, there's not these extreme high or extreme low values that aren't balanced out, that the mean